Okay, so picture this. It's GTC 2026. Nvidia gets on stage, and instead of just showing off a new chip, they unveil a whole new philosophy for building artificial intelligence. We're talking about the blueprint for what they're calling an AI factory, a platform named Vera Rubin that is set to completely redefine how we even think about AI infrastructure. So let's dive into what that could mean.
And it all kicks off with this powerful declaration from NVIDIA's CEO, Jensen Huang. Now, this wouldn't just be some marketing slogan. A statement like this signals that AI agents, these autonomous systems that can actually reason, plan, and act on their own, they're no longer just a cool research project. They are ready for production. And that changes everything.
You have to understand, the context for an announcement like this would be absolutely wild. Imagine the entire industry in an all-out sprint. In just the 3 weeks leading up to this hypothetical GTC, we could see count them, four major new models released. GTC really acts as a forcing function. NVIDIA circles the date on the calendar, and everybody else rushes to get their latest and greatest stuff out the door right before. The pace would be just breathtaking.
But what's really fascinating about a GTC like this is how the whole conversation would fundamentally pivot. In past years, it was all about benchmarks, demos, and what AI could theoretically do. Here, the focus would be entirely on enterprise-scale agentic AI that's already up and running in the real world. The question is no longer, is this possible? It's, okay, how do we manage this thing at massive scale?
All right, so here's our game plan for breaking this all down. First, we're going to look at the new bottlenecks that the old hardware just can't handle. Then, we'll take a tour inside this Vera Rubin AI factory, we'll meet the 3 specialized chips that are at its very core, and then finally, we'll wrap up with the new AI playbook that this whole platform opens up. So, to really get why Vera Rubin is such a big deal, you first have to understand the problems it was built to solve. See, as AI models got bigger and way smarter, they started running into some fundamental walls. We're talking massive traffic jams inside the system.
The first bottleneck is all about how these language models think. Generating a response is actually a 2-step process. The first part is called prefill, where the GPU gobbles up your entire prompt all at once, in parallel. GPUs are amazing at this. But then comes step 2, decode. This is where the model generates the answer one word or token at a time. And because it's sequential, one after the other, it creates this huge traffic jam where the bottleneck isn't raw compute power, but how fast you can feed the chip data from its memory.
And then there's bottleneck number 2, and this one is specific to training AI agents. In reinforcement learning, you have a super powerful GPU that suggests an action, but then it has to just wait. It sits there twiddling its thumbs while a much slower CPU runs that action in some simulated world to see what happens. Your multi-thousand-dollar GPU is literally waiting on the CPU to finish its homework. It's a massive inefficiency that just grinds the training process to a halt.
So, you've got these 2 huge problems. How do you solve them? Well, NVIDIA's answer wasn't just to build a bigger, faster, do-it-all engine. Nope. Instead, they built a specialized factory. So let's step inside the Vera Rubin platform.
And this isn't just one chip, not even close. It's a whole rack-scale system with 7 specialized coprocessors all working together in perfect harmony. You've got the main Rubin GPU doing the heavy lifting, all that training and prefill work. Then you have a language processing unit, an LPU from Grok, whose only job is lightning-fast decoding. And then there's the brand new Vera CPU, built to run those reinforcement learning environments. The rest of the components are all about connecting these 3 and feeding them data at just mind-boggling speeds. And this right here perfectly illustrates the massive shift in thinking. The old way was like having one giant, super powerful engine and telling it to do everything, from hauling heavy loads to doing delicate assembly work. It's not efficient. The new way is an assembly line. It's a factory full of specialized workers. Each one is an absolute expert at its one specific job. And working together, they're so much more efficient than that one big engine could ever hope to be. Okay, so let's zoom in a bit and meet the 3-star workers on this new AI factory floor. The Rubin GPU, the Grok LPU, and the brand new Vera CPU. First up, the Rubin GPU. And just look at these numbers compared to Blackwell, the previous generation. We are not talking about small 10% gains here. We're seeing a 2.5 times leap in inference performance and nearly triple the memory bandwidth. This is a true generational leap, in every sense of the word. Let's just pause on that 2.5x number for a second.
This huge jump in inference power is precisely what lets you run these enormous AI agents that can understand and process incredibly long contexts. We're talking millions of tokens. This is the raw horsepower that the new era of AI needs.
And then there's this number, 22 terabytes per second of memory bandwidth. Think of this as the width of the highway that feeds data to the processor. Having a highway this wide is what makes processing a million token context practical, not just a theoretical possibility. It's the key that unlocks truly deep, comprehensive understanding for AI.
But look, performance is only half the battle. The real magic of this whole factory approach is the efficiency. By having specialists for each and every task, the full Vera Rubin platform delivers a staggering 90% reduction in the cost to generate every single token. This is what takes agentic AI from being an expensive toy for research labs to a scalable, affordable tool for businesses.
Now, to solve that decode bottleneck we talked about earlier, Nvidia made an absolutely brilliant move. They went out and bought Grok for a cool $20 billion. And you have to ask why. Because their technologies were a perfect match. Nvidia already ruled the world of AI training and prefill with their GPUs. Meanwhile, Grok had absolutely mastered the art of ultra-fast decoding with their specialized language processing units, their LPUs.
So you see, this wasn't about squashing a competitor. Not at all. This was Nvidia looking down the road, recognizing the limits of a GPU-only world, and buying the absolute perfect solution to their own biggest future problem. It was a strategic masterstroke, an embrace of this new era of specialized, heterogeneous computing.
And that brings us to the third specialist, the Vera CPU. This is, get this, the world's first processor designed specifically for agentic AI. Its one and only job is to run those complex environments for reinforcement learning at incredible speed. With 88 powerful ARM cores and its own insane memory bandwidth, it's designed to completely obliterate that second bottleneck we talked about, letting the GPUs learn 24/7 without ever having to wait.
So, we've seen the hardware, we get it, but what does this new AI factory actually mean for businesses, for developers, for the future of AI itself? Well, it enables a completely new playbook.
Nvidia is calling it the fourth scaling law. See, we've already gone through these different eras. The first was all about scaling model size. The second was about scaling human feedback data. The third was about scaling raw inference compute. Well, the new frontier, this fourth law, is all about agent scaling. And the key metric is no longer just how humans talk to AI, but how AIs communicate and collaborate with other AIs. This is the infrastructure built for that world.
So what's the bottom line here? What should you take away from all this? I think it boils down to three huge things. First, agentic AI is here. It's not an experiment anymore, it's a production-ready technology for the enterprise. Second, the best AI models are becoming commodities. That means your competitive edge is shifting away from which model you use to how you design clever agent workflows. And third, the era of the GPU trying to do everything is officially over. The future is a factory of specialists.
So, Nvidia has laid the foundation. They've built the factory floor, the assembly lines, the specialized machines, all for this new age of agentic AI. And that leaves us with the only question that really matters, and honestly the most exciting one of all. What will the world build with it?